it is now time for lesson 2.3, graphing linear equations in slope-intercept form. And if you had 7th grade content last year, you're probably familiar with the whole y equals mx plus b form. There's actually two other forms of a linear function, but we're only going to talk about y equals mx plus b today. So a linear equation, an equation that forms a straight line on a graph, can be written in the form of y equals mx plus b. That's called slope-intercept form. In this form, the slope of the line is m, and the y-intercept is the b. So it's called slope-intercept form because this form gives you the slope and it gives you the intercept just by looking at it. You don't have to really figure too much out. It's nice. The y-intercept of a line, what is that, you say? It is the y-coordinate of the point where the line crosses the y-axis. It's the value of y when x is 0, basically. And we're going to talk about x-intercepts too. That's the point of a line where the x-coordinate, where the line crosses the x-axis. So it's a value of x when y equals 0. So y-intercept, x equals 0. X-intercept, y equals 0. So in taking a look at this little picture, here's the y-axis. This point crosses the y-axis. This is your y-intercept, and notice x is 0. This is a point where the graph touches the x-axis. That makes this the x-intercept, and notice, that's a comma, not a 10, that's what happens when y equals 0. So it's kind of an opposite thing going on. Maybe you've noticed in math, opposites have a lot to do with a lot of things. All right, so y-intercept crosses the y, x-intercept where it crosses the x. You can easily identify the slope and y-intercept of an equation that is written in slope-intercept form. When an equation is in slope-intercept form, the slope is the coefficient. There's that word again. That's never going away. My son is trying to play the flute down here, so sorry about that. Quiet, Ethan, okay, buddy? Just watch the lesson. My 5-year-old is learning slope and y-intercept. He's going to be way ahead of the game. All right, so when an equation is in slope-intercept form, the slope is the coefficient of x, and the y-intercept is the constant, but it needs to be in that form, y equals mx plus b. So when you have the y isolated, that's when you can identify the slope and y-intercept from the equation. So let's try it. Look at letter A. Zoom in just a little bit here. All right. So here I have y equals negative 4x minus 2. I'm still going to want you to get in the habit of adding the opposite here, because otherwise we might think the b is something that it's not. So take a look. In this equation, the slope, or m, we can refer to the slope as m, it's the coefficient of x, and yeah, the number in front of the x is negative 4. That makes my slope negative 4. I told you that the b is the constant. It's the one that's being added to the variable term, the one that doesn't have an x next to it. Yeah, that would be negative 2. So my b is negative 2. I know, it's really that easy. All right, follow over to letter B here. Again, I'm going to do keep, change, change, keep, change, change, so that I don't think my slope is a positive 12, because you can see that the coefficient of x is actually a negative 12, because subtracting 12 is the same thing as adding a negative 12. So slope, negative 12. The number that's all by its lonesome on the same side as the variable term is 4. So my y-intercept is 4. Another way to look at this, if you wanted to be fancy about it, if we're going to plot it, it's really 0, 4. And that other one, I'm sure you can guess, is 0, negative 2. All right. So when you look at letter C, you knew it had to get a little bit more complicated, right? In this, my y-intercept, my b, isn't actually a negative 5. Because remember, this has to be in the form of y equals mx plus b. So I need to isolate the y if it's not already isolated. So let's do that. Let's get this 5 out of here. This is really a negative 5, so to move it, I'm going to add a positive 5 to each side. So the equation I'm actually working with is y equals 3 has x plus 5. Now it's easy to identify the m and the b. The m, or slope, is this 3 halves. Don't put the x after it, just put the number, please. And the b, the one that's by itself, that would be this positive 5. Also, you could write it as 0, 5. Next, again, check it out. Y is not alone yet. Y really likes to be alone. So we're going to give y what it wants and add a -3 to each side, or subtract 3, whatever floats your boat. So y is equal to -x plus -3. Okay, I chose this example for a specific reason. When you go to identify the slope, a lot of people want to tell me that the slope is -x. Isn't the slope supposed to be a number that represents the steepness of the line, the rise over the run? If we call slope -x, we're not going to know where we're supposed to move. The slope is the coefficient of the x. And when you just see a negative sign, you need to recall that this really means -1x. So my slope is -1. The b in this one is -3, or 0, -3. All right, moving on to E. Let me make sure I'm focused here. All right. Now I really need to get y by itself. Y's got all kinds of things that are bugging it. It says, get out of here, -6. I want you gone. So we're going to add 6 to each side first. 2y equals 3x plus 6. Now that 2 needs to go away as well, because y is not alone yet. So if I divide that by 2, I need to divide each term by 2. So y is really equal to, and again, slope is okay in the form of a fraction, 3/2 x plus 6 divided by 2 is 3. Now we can identify the m and the b quite easily. M is the coefficient of x, which is 3/2. B is the constant, which is 3. The point on the graph would be 0, 3 for that one. All right, we're almost there. I had to include some fractions here. I'm trying to give you a variety so you'll know how to attack each different kind of problem you see. And I'm not trying to bore you with example after example. You've noticed that all of these have kind of had something special about them. That's how I roll. All right, draw the line. I have this -1/2 here on the same side as the x. I want it gone. So I'm going to add the opposite of it. And y is equal to x over 4 plus 1/2. Okay, so I'm guessing the b isn't going to be too difficult for you to identify. The b, yeah, it's 1/2. That means my y-intercept is 0, 1/2 if I was plotting that. Sorry, I'll make it so you can see it. Now, about this little slope here. The slope is the coefficient of x. What's the number in front of the x? Because the slope isn't 4, right? 4 is in the denominator. There's a 1 in front of the x, right? This really means 1/4 x. This can be written as that. It all means the same thing. I'll move it so you can see it. There you go. So 1/4 x is the same as x over 4. My slope is 1/4. So be careful with problems like that. Okay, so if I give you an equation, as long as you have it in slope-intercept form, y equals mx plus b, you can find the slope and the y-intercept really easily. Slope is the coefficient of x. Don't write the x. The y-intercept is the constant, the thing that's being added to the variable term. And make sure you do keep change. All right, go to your next page. So finding the y-intercept is pretty easy if it's in y equals mx plus b form. The x-intercept isn't quite as easy. It's not too bad. It's just not as easy as looking at an equation. So if you look at this, it says the x-intercept, if you recall, it's the value of x when y is 0, right? On a graph, it's where the line crosses the x-axis. So basically, if we have an equation, if we know that the x-intercept happens when y equals 0, all you need to do is plug 0 in for y and solve the equation for x, and you'll have your x-intercept. So take a look. I have y equals 5x minus 10. I want to know the x-intercept, so I'm going to plug 0 in for y and find out when y is 0 what x is. So let's solve this. I want the x by itself, so I need to get rid of this 10 right here, and it's minus 10 or negative 10. So I would start by adding 10 to each side. So 10 would be equal to 5x. Now I want x all by its lonesome, which means I need to divide each side by 5. And we get x equals 2. Yup, that's the x-intercept. But when you list an x-intercept, remember it's the value of x when y is 0, so this would actually be 2, 0. That's the x-intercept. Not 0, 2. That's the y-intercept. All right, look at letter B. Again, the x-intercept happens when y equals 0, so let's just plug 0 in for y. and then we get to solve this equation for x. So starters, let's get rid of this positive 4. Remember, that's a negative 12 because we're adding the opposite there. To get rid of this positive 4, I'm going to add a negative 4 or subtract 4, whatever, same thing. And negative 12x would equal a negative 4. Now I want to get rid of this negative 12. That means I have to divide by it. So x equals, well, a negative divided by a negative is a positive, and 4/12 isn't 3 because it's not 12 divided by 4. It's 4 divided by 12. So in simplest form, this would be 1/3. So that means my x-intercept, when x is 1/3, y is 0. That's how I would list it as an ordered pair, and that's how I would graph it. Right, for letter C, if you wanted to, you could rearrange this equation into y equals mx plus b form. You don't have to. Just plug 0 in for the y, because the x-intercept happens when y is 0. So I'm going to say 0 plus 3 equals negative x. And does anybody know what 0 plus 3 is? I do. It's 3. 3 equals negative x. I don't want to know what negative x is, though. Nobody wants a negative x. I've said that a million times. Remember, if you have a negative x, it really means negative 1x. So to get rid of that negative x, I'm going to divide by negative 1. And x would equal negative 3. And again, if I was plotting my x-intercept, that means x is negative 3 and y is 0. All right, last one like this. I have 2y minus 6 equals 3x. I still want to know what's the value of x when y is 0. So if you want to rearrange this, go for it. But I could just plug 0 in for y and say 2 times 0 minus 6 equals 3x. 2 times 0 is 0, and 0 minus 6 is negative 6. So negative 6 equals 3x. I'm going to divide by 3 to get x all alone. This time x wants to be alone. And negative 6 divided by 3 is negative 2. So again, if I was plotting that on a graph, that would mean when x is negative 2, y is 0. So again, all the y values are 0 in an x-intercept. All right, so hopefully we know how to find y-intercepts and we know how to find x-intercepts. The last part of today is graphing equations that are in slope-intercept form. So what I'd like you to do, if you don't have a ruler handy, I'd like you just to pause me for a minute. I know you wish you could do that in real life too. But pause me for a minute, grab a ruler and come back. Hello, welcome back. All right, graphing equations in slope-intercept form. So here are some little steps for you. You can refer back to these. You're going to be using these a lot this year. First off, if you're going to graph an equation in slope-intercept form, you need to make sure the equation is solved for y. You have isolated the y. It is in y equals mx plus b form. Then, place the y-intercept, or the b, on the y-axis. Then, make sure your slope is in the form of a fraction, and you're going to count the rise over run to find another couple of points on the line. Remember, I like 3 points, 3 pointers. And remember, you're not starting your movement for your slope from the origin. You're starting it from your y-intercept. So let's try a few. Usually the examples are what helps all of this make sense. So here is our first example. It is y equals 4 minus 5x. Now in looking at this, it's nice because y is already alone. I'm going to go ahead and add the opposite here so I know I'm dealing with a negative 5. So our step 1's good. Number 2 says to place the y-intercept on the graph. So the y-intercept, the b, that's 4, right? So I'm going to go up 1, 2, 3, 4 on my y-axis. Step 3 says to make sure your slope is in the form of a fraction. Right now, the coefficient of x is not a fraction, but whole numbers are really easy to make fractions. All you do is put a 1 underneath it. So now I have my rise and I have my run. So we're going to use that to find other points in the line. So starting from this, if my slope is negative 5 over 1, that negative 5 means vertical movement is down 5. So from here I'm going to go down 5. 1, 2, 3, 4, 5. And the denominator is a positive 1. That means on my x-axis I'm going to go right 1. And I want you to do that one more time from this point. So if the slope is negative 5 over 1, that means down 1, 2, 3, 4, 5. Positive 1 means right 1. You could do that forever and ever, but I don't really think I give you enough space. Now you can take a line, your ruler, and make a line and you have just graphed all of the solutions to y equals 4 minus 5x. Not too bad. All right, take a look at what happens when y is on the other side. Nothing different happens. The y is already isolated by itself. So it's solved for y. Step 2 says, place the y-intercept on the graph. Well, there's the constant. There's the one by itself. It's a -1. So I'm going to plot -1 on my y-axis. This says -2/3 x, right? We were subtracting 2/3. So when you add the opposite, it doesn't matter if you put it with a 2 or the 3. I'll put it with a 2. Why not? But this is a -2/3 here. That means my line should be decreasing, kind of like the other one here that had a negative slope. So from my y-intercept, -2/3 means my y movement is down 2, and my x movement is +3. So write 3, 1, 2, 3. I'm going to do that one more time. Down 2, right 1, 2, 3. And just to show you for fun, because I know it's so much fun, if you would have put the negative with a 3 instead and wrote 2 over -3, when you start at this point, 2 over -3 would mean up 2 and left 3, wouldn't it? And isn't that still a point on the line? So it doesn't really matter where you put the negative sign as long as you put it with one of them. And usually it's with the top, but it does not have to be. So there are all the solutions to y equals -1 minus 2/3 x. Okay, of course I have to show you one that's not solved for y, because what kind of teacher would I be if I didn't show you several types of examples? So in this equation, before you begin, we have to have y by itself. There's a -2 on the same side of it. I need to add 2 then, so that it goes away. So y equals x over 4 plus 2. Now that's your first step, solving for y. Your second step is to go ahead and place the b on the graph. Ah, there's a b on the graph. Sorry, I don't know. Maybe that's too much. Anyway, there's 2 all by itself. I'm going to go up 2 on my y-axis. Now you've seen this x over 4 before, right? This really means 1x over 4. That means my slope is up 1, right 4. So from my y-intercept, I'm going to go up 1 and right 1, 2, 3, 4. And I'm going to do that again, so I have 3 points, up 1, right 1, 2, 3, 4. If after you plot these points, they don't make a straight line, it probably means you have done something wrong. So you should go back and check it out. All right, and notice that the slope's a positive, right? And look at that. The graph's going up. Lovely. Okay, look at letter D. It says y equals 3x. Okay, it's solved for y. You're supposed to place the y-intercept on the graph, but I don't see anything. So when there's nothing there, it really means there's nothing there. When you don't see a b, it's 0. This graph is going to cross the y-axis at 0, 0. All right, so now I need my slope to be a fraction. I'm going to write that 3 over 1. And from my y-intercept, I'm going to go up 1, 2, 3, and right 1. And I'm going to do that one more time. Up 1, 2, 3, right 1. And draw my line. All right, couple more, and we'll be home free. Because we have to have some special cases, don't we? All right, here I have y equals -6. Yep. So your first job is to have the y isolated. It is. It's all by itself. Second step, place the constant on the graph. Well, this -6 doesn't have an x next to it. That makes it the y-intercept. So I'm going to go down 1, 2, 3, 4, 5, 6 on the y-axis. Do you see an x? There isn't an x. What's 0 times x? Don't say x. 0 times x is 0. So my slope of this is 0. Do you remember that when you saw equations solved for y without an x that they were a horizontal line? It's still true. That's it. Y equals -6 is a horizontal line that crosses the graph at y equals -6. For letter F, yep, there isn't a y, but I'm hoping that you remember if you just see x equals 5, that means that on my x-axis, x will always be 5. So this would be a vertical line that crosses the x-axis at 5. So y equals horizontal, x equals vertical. And the last one, I don't know why, but this one always messes people up. I just have y equals x. So that means when y is 1, x is 1. When y is 2, x is 2. When y is negative 100, x is negative 100. We can do this the same way. First off, notice it's solved for y already. It's solved for x too. And there's no plus b. That means that my b is 0. So y-intercept is 0. Remember, when x doesn't have a number in front of it, there's really a 1 there. To write that as a fraction, because I want my slope, the coefficient of x, to be a fraction, I'm going to put a 1 underneath it. So that means from here, all I need to do is go up 1, right 1, up 1, right 1, up 1, right 1. And notice, when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. When x is 10, y is 10. So basically, when you see y equals x, you're going to see a lovely line that kind of cuts this graph right in half. Looks like that. All right, looking forward to doing some more practice with this tomorrow in class. See you then.